All right, chemical reactions. Pretty important, some would suggest. Pretty important part of the world and the way that it operates. Why do they occur, Buck? How?
Atoms don't have a full shell.
So atoms that don't have a full shell want to do what?
They want to exchange.
So you're right that they want full valence or outer shells, and they will gain electrons or lose electrons to get that way. But not all reactions involve the giving of an electron or the taking of an electron. Let's look at a chemical compound we're familiar with, O2. Oh, it's an element, but it's a molecule, correct? How many electrons does oxygen want to get a full outer shell? Jack? One? Does it want one? How many away? It's two away. So it wants 2 electrons. How many to get a full outer shell? 8. So how did 2 oxygens make it so that they both have 8 in their outer shell? They're both happy. If I was to draw an oxygen atom here, let's just draw the outer shell. Okay. It's going to draw 1, 2, 3, 4, 5, 6. Other one, I'm going to do the same thing. What if these moved a little bit this way? What would it be like? How many would each have in its outer shell? Would it? No, no. These ones stay, that they're the same. I'll just draw rings around them. I'll draw these ones a little bit closer. 8. What have they done? Have they given their electron? Because if they gave their electron, what would one be happy? One would be, one wouldn't be. That's not thinking win-win. How about those 7 habits, eh? Instead they share. So this one lets the left, your left, the left oxygen lets the right oxygen have one of its electrons. Doesn't have shares. So it borrows, sort of holds onto it. The right one does the same for that one. Down the bottom we've got the same thing. I was thinking about doing a prac. So let's do it. So physics. Kyle, up you come. Well, up you come. These are electrons. Only going to be happy if you're both touching 8. Then you can put them in your pockets, you can do whatever you want. Happy with that? There's 3. You get 6. So there's your 6.
Wait, so how many do we need?
Actually, I'll give you 3 of the hard ones each. Okay. There. You get 1 more. So there's your 6. Now you need to be touching 8. You can put them in your pockets, you can do what you like, but you need to be touching 8.
Why?
Okay.
Steal that one.
So Kyle's put 2 in his pocket.
4.
How many are you going to put in your pocket?
4.
You have put 4 in your pocket. How many you put in your pocket? I'll do what Kyle's doing.
Do 4, and then you hold 2, and I hold 2.
But then you're still only holding 6. You need to be touching 8, either with your pants or in your hands. Your pants that you've got, you're touching 6.
4.
Yep.
Yeah, and then we share them.
Very interesting. But you're only touching 6 now. You have to actually physically touch it. Now, Will, you're only got 7.
Yeah.
There we are. Does that make sense? So what are they doing? Sharing their electrons. Are they happy?
Yeah.
They both got 8 electrons in their outer shell. Cool?
Yeah.
Sweet. Whoa, I'm not done yet.
Oh.
All right, you need to have 7.
Surely I don't have to have.
You get 1. Now, one of you must be holding. You still got more. One of you must be holding 8.
Oh.
Touching 8. One of you
us.
must be touching 8.
Do I have to have any?
No. What's happened there?
He stole them.
It's much easier for Cole to give his 1 away. Very good. Put those back. So what type of elements have 1 or 2 or only a couple of electrons in their outer shell? Starts with M, the word I'm wanting. I'll give you a few seconds. What have we got there, Zara? Left side of the periodic table, they're all metals. What are things that like or almost have a full outer shell? Yeah, a lot of them are gases, but they are non-metals. So do metals ever want to share? Not very often. Do non-metals ever want to give? They're pretty close to a full outer shell. They don't want to give any away. So what kind of elements would you expect to want to share? Well, a metal wants to give away normally, doesn't it? So you've got someone that wants to take and someone wants to give. Are they going to share? What scenario are you going to have where they want to share, Jack?
And they're both close to having full energy.
Which are both non-metals. Clear with that?